Okay, I'm going to run through the problems in your assignment here. Again, you should try these problems before you watch them worked out. That way you can kind of see if you're getting it or not, and then of course if you're not getting it, if you're not matching an answer with the key, then of course you can always check to see how the problems are worked out by me and see if that gives you some insight. And of course you can always give me a quick call about any of these problems, or a long call about any of these problems that you have questions on. Alright, I listed out here all the different formulas. Here's the arithmetic sequences, which are not used in this assignment. And here are the geometric sequences, also arithmetic series and geometric series. These four formulas you're going to need to put to memory. Okay? You should memorize those. Now, I know that your teacher kind of wrote this one different than the way I write it. If you like his way of writing it, that's fine. It works. Okay? The first 6 problems are asking you to find the common ratio of each geometric sequence. What's nice about this is that they say it's geometric, therefore it has a common ratio. Remember, arithmetic, they get bigger or smaller by the same amount. You're adding or subtracting, you're adding a positive or you're adding a negative for subtracting number to go from one term to the next term to the next term to the next term. Like 5, 10, 15, 20, 25. That's arithmetic, and your common difference is 5. But with geometric, down here, geometric, you have a common ratio. You're multiplying by the same number. It might be positive, it might be negative, it might be a number greater than 1, it might be a number between 0 and 1. If it's greater than 1, the numbers are going to get bigger. If it's between 0 and 1, the numbers are going to get smaller. If you see the signs are alternating from positive to negative to positive to negative, that means your common ratio is negative. Okay? So in this case here, I know it's geometric. All you've got to do to find the common ratio is take 2 consecutive terms. I'll just take the first 2 because they're fairly small. And you write the ratio. The ratio being the second term over the first term. And so my common ratio is 4. That was easy. All you have to do are take the 2 consecutive terms. It doesn't matter which 2 terms. Look, if I take these 2 terms and I write the ratio, the second term to the first term here, or in this case the fourth term to the third term, I would get 64 over 16. Well, 16 goes into 64 4 times. It doesn't matter what 2, if it's geometric, it doesn't matter which 2 you take, they just have to be consecutive, and it's the one to the right over the one that's further in the sequence to the one before it. The one that's after it until, over the one that's before it. Same thing here. My ratio, I'm going to take the first 2, would be 6 over 3, which is 2. Easy pleasy. Now this one, the signs are changing from negative to positive, and so on. So that's a pretty good tip-off. Your ratio is going to be negative. And you'll see that. I'll just take the first 2 again. 6 over negative 3. Well, 6 divided by negative 3 is negative 2, and my ratio is negative. Now here the numbers are getting smaller. They're all positive, so my ratio is positive. But because the numbers are getting smaller, I'm going to bet you a quarter that my ratio is going to be between 0 and 1. So you take any 2 consecutive numbers. Now, if I take these 2, they're a little bit bigger. So I'll take the last 2 because they're a little bit smaller. It might be easier to simplify if it simplifies. So that'd be 17 over 34. And divide top and bottom by 17, this is a half. The ratio is a half. Like I said, it's going to be between 0 and 1. Here they're getting smaller. Now, I don't want to really mess with the fraction one down here. I think I can avoid it. I'll take these 2 right here. I'll write the ratio. It would be 8 over 20. Notice it's the one on the right over the one on the left. The consecutive. So 8 over 20, you can divide top and bottom by 4, you get 2/5. Here's another one where the signs are alternating, and they're all fractions this time, so you got to be careful when you do your ratio with fractions. I'll take the first 2. My ratio is 1/8 over negative 1/4. Now remember, this is division. The numerator divided by the denominator, so this is 1/8 divided by negative 1/4. And you may remember with fractions, when you divide, you have to invert the divisor and multiply. So this becomes 1/8 times the reciprocal of negative 1/4, which would be negative 4 over 1. Positive times a negative is a negative. 4 goes in that once, goes in that twice. It looks like it's going to be negative 1/2. And that's the first 6 problems. Now, if you have lots of problems like that on the assignment or on your test or quiz, that's good because you can see how fast they go. You just have to be careful with your science and your arithmetic. A little bit different here. It says decide if the given sequence is arithmetic, geometric, or neither, if it's arithmetic, identify the common difference, D, and if it's geometric, identify the common ratio, R. Okay, so I'm going to check first for arithmetic, then I'm going to check for geometric, and if it's neither one, I know my answer is neither. Arithmetic. Arithmetic has a common difference. What that means is if you take any two terms and subtract second one minus first one, you get the same answer each time. For example here, if I'm trying to subtract here, I get the first two, I get 24 minus 6 for my common difference. That's 18. But if I do the next two here, look what happens. My common difference is now 96 divided, or minus 24. What is that, 72? I do not have the same common difference. I'm not even going to have to mess with the next one. So I already know it's not arithmetic. These are going to have to be the same. I'm going to have to check first two, middle two, last two. I have to make sure that all three would be the same. Well, as soon as I see that the first two are not the same, I can stop. I don't have to do any more. Now I'll see if it's geometric. So my common ratio, if it's geometric, would be the second one over the first one. That would be 24 over 6. My common ratio would be the second one over the first one. That would be 96 over 24. My common ratio would be the second one over the first one here. I'm looking at these two now. So that would be 384 over 96. Now if I get the same answer, if these turn out to equal, I'm good. That means it's geometric. Well, 24 divided by 6 is 4. 96 divided by 24 is also 4. And 396 divided by 394 divided by 96, get your calculator out, it's also 4. So this is geometric, and my common ratio is 4. All right, next one up. I have 1, 3, 7, 13. So again, first I check to see if it's arithmetic. See if it's arithmetic, I'm going to look to see if I have a common difference. 3 minus 1, 7 minus 3, 13 minus 7. Well, this is, let's see if these are equal. 3 minus 1 is 2, 7 minus 3 is 4, 13 minus 7 is 6. These are not equal. I do not have a common difference. Not arithmetic. I think there's at least one of them in here that is. So if it's not arithmetic, then I'll check to see if it's geometric. If it's geometric, I have a common ratio. Second one to the first one, 3 over 1, 7 over 3, 13 over 7. Well, I can tell you right now, those are not equivalent fractions. So it's not geometric as well. Notice again where 3 over 1, 7 over 3, 13 over 7. Not the same. If the first two are the same but not the last one, it doesn't count. It's not geometric. So it has to be a neither. Now, don't forget to write down neither. You know, if you just erase the geometric and the arithmetic and you leave it blank, the teacher's not going to know if you know what you're doing or not. So now I'm going to try problem 9, 10, 11, 12, same way. I'm going to go through the same steps. So first I'm going to see if I have a common difference. So I have 13 minus 4. Does that equal 22 minus 13? Does that equal 31 minus 22? Well, 13 minus 4 is 9. 22 minus 13 is 9. 31 minus 22 is 9. That's it. They have a common difference here. Therefore, I'm going to erase this because I don't have much. Well, I'll just erase this part here. It's arithmetic. I don't have to check for the other. And my common difference is 9. Next one up. I'll check again. First, if it's arithmetic. So, if it's arithmetic, my common difference would be negative 1 minus 3, or negative 5 minus a negative 1, or negative 9 minus a negative 5. Careful with all those negatives. And I'll see if these are equal. If they're equal, then I know it's arithmetic. Negative 1 minus 3 is negative 4. Negative 5 minus a negative 1 is like adding the opposite. That's negative 4. Uh-oh. It's like adding the opposite. That's a negative 4. They're all equal. So I have a common difference. So just like I did on the problem before that, since I have a common difference, I know it is arithmetic. And my common difference is negative 4. Sometimes the common difference is positive, sometimes the common difference is negative. All right, next one up. There's my answer there, by the way. Next one up. I'm going to check to see if it's arithmetic first. So if it's arithmetic first, it should have a common difference. So second one minus the first one, negative 7 minus a negative 11, negative 3 minus a negative 7, 1 minus a negative 3. I think this one's going to work also. I'm going to check to see if these are equal. Those are question marks there. Negative 7 minus a negative 11 is like adding the opposite, that's 4. Negative 3 minus a negative 7, that's like adding the opposite, that's 4. And negative 1 minus a negative 3 is like adding the opposite, that's 4. They're equal. So I have a common difference. So like the last two examples, since I have a common difference, let me get rid of this here so I have some space. I know that this is arithmetic. And I know my difference in this problem is 4. Next one up. Whoa, what a pain this is going to be. First I'm going to check to see if it's arithmetic. If it is, it has a common difference. So that would be the second one minus the first one. The third one minus the second one. The fourth one minus the third one. Well, this doesn't look like this is going to work. 3 over 2 minus 1 over 2 is 2 over 2, which is 1. 9 over 2 minus 3 over 2 is 6 over 2, which is 3. I can stop. I don't even have to worry about this guy. This guy turns out to be 9. So, definitely not arithmetic. Now I'll see if it has a common ratio. You have to be careful. Remember what I did over here to find my common ratio? I did the division. I'm dividing because I have fraction over fraction. So for the first one, it's 3 halves over 1 half, which is 3 halves times the reciprocal, which is 2 over 1, which is 3. Now I'll try the next two. So it would be this one over this one, so my ratio would be 9 halves over 3 halves, which is 9 halves times the reciprocal, which is 2/3. I got a 3. I'll try one more here. Do the fourth one over the third one, that would be 27 over 2 all over 9 over 2. That's 27 over 2 times reciprocal 2/9. The 2's cancel. 9 goes in that. Look at that. I got a 3 again. So I have the same ratio each time, which means it's geometric, and my ratio is 3. I erased it all, so I got to remember that my ratio is 3 and that it's geometric. Okay. Now, you have to be careful. He didn't have any examples like that, but it is possible that if you check the first two, you get 3. You check the next two, you get 3. But if you check the last two, maybe you get a different number. He might try to sneak one past the goalie there, throw a little bit of a curveball at you. Next guy up, we are to find the rule or formula for the nth term. Remember, this is the nth term, this guy right here. Now to find the nth term, what do I need? I need the first term, and I need to know the ratio. Oh, I almost pointed that. I need to know the ratio, the common ratio. So, look what they did. You couldn't have asked for an easier problem. They gave you the ratio, they gave you the first term. So a sub n is equal to 45 times the ratio to the n minus 1 power. The ratio is 1/3, so that's this guy right here. I did put the parentheses around the 1/3 to imply multiplication here, and that all this was being raised to the n minus 1 power. That's as easy as they get. Now they get a little trickier here. This next one, they give you the ratio, but they don't give you what a sub 1 is. That's okay, they give me a sub 3. So that means when n is 3, I get 72. So going back to here, a sub n, or a sub 3 in this case, would be equal to a sub 1 times r, which I know is 6, and I have to put that in before I forget, 6, to the 3 minus 1, because I'm doing a sub 3 here, that was what they gave me. 3 minus 1 power. 3 minus 1 power, and this equals 72. So this is a sub 1. Now 3 minus 1 is 2, so this is 6 squared, or 36, equals 72. Divide both sides by 36, and it does divide into it evenly. I get a sub 1 is 2. Now I have exactly what I need. I need this, I need this. So I'll put it over here. A sub n is equal to a sub 1, which is 2, times my ratio, which is 6, to the n minus 1 power. And this is my answer, right here. Now the last two get even a little bit more intriguing in that they don't give you the ratio, so you're going to have to find that. Now what's kind of nice with 15 is at least they gave you a sub 1. And they also gave you a sub 6. So I'm going to start with a sub 6 and go right to there. A sub 6, which would be a sub 1, which is negative 1/2, times r, which we don't know, which we have to find, to the 6 minus 1 power, because that's our n here, that's our n, is equal to negative 16. So this is negative 1/2 r to the 5th is equal to negative 16. I'm going to solve for r, and I'm going to multiply both sides by the reciprocal of negative 1/2, which is negative 2. So negative 2 times this side and negative 2 times this side. So this is going to cancel. I'm going to get r to the 5th is equal to positive 32. This is nice. R to the 5th, what number times itself, times itself, times itself, times itself is 32? Well, 2 is. 2 times 2 times 2 times 2 times 2 is 32. R is 2. Now I have everything I need. So right over to here, I can write a sub n is equal to a sub 1, which is negative 1/2, times my ratio, which is 2 raised to the n minus 1 power. Now this one I think I did the other day on the video I was making, but I might have ran out of memory because I know that the camera stopped on me and I just kept on going because I didn't hear it click. So I'm going to go ahead and work this one out all the same. And this one's the worst one out of the three, out of the four actually, because they don't give me a sub 1, they don't give me r. I'm going to have to do a system. I'm going to have to use 2 bits of information to come up with 2 equations with the unknowns of a sub 1 and r. I wish there was a faster way. There really isn't. I mean, I suppose you can play around with it trying to figure out factors and work kind of backwards, you know, like what times this, times this, you know, times the same number, times the same number, times the same number gives me that. Actually, I think I know what it is, but I'm going to go ahead and show you how to do this in case it's not so convenient. Back to here, a sub 3 is equal to a sub 1 r to the 3 minus 1. 3 minus 1, because I'm doing a sub 3, n is 3. And according to this is equal to 10. So that means a sub 1, and this is r squared, equals 10. There's one equation. Now I use this. A sub 6, so n is 6 here, is equal to a sub 1 r to the 6 minus 1, and according to this is equal to negative 270. Now 6 minus 1, of course, is 5, so I have a sub 1 r to the 5th is equal to negative 270. I have 2, and I have to find out the equation. So I have to find out what a sub 1 is, what r is. So I'm going to take this first one, and I'm going to divide both sides by r squared, and I'm going to use substitution. I get a sub 1 is equal to 10 over r squared. And I'm going to plug all of this in right there. So I have 10 over r squared times r to the 5th is equal to negative 270. Now look, you see the variables? R to the 5th is like r to the 5th over 1. These two factors cancel out with 2 of these. 5 minus 2, it leaves 3 of them. So I have 10r to the 3rd all over 1, which is just 10r to the 3rd, equals negative 270. Divide by 10. I get r, I'll bring it up here, I get r to the 3rd, negative 270, divided by 10 is negative 27. What number times itself is negative 27. That'd be negative 3. There's r. Now look, I can plug r right into here, this is a 2 here, and I can find a sub 1. So after I substitute and get 1, I plug back into either equation, it doesn't matter which, this is just a little simpler, and I get a sub 1 is equal to 10 all over negative 3 squared, which is positive 9, right? Negative 3 times negative 3 is 9. So a sub 1 is 10 over 9, and don't change it to a decimal, it's repeating. So just go ahead and plug it right into this guy. Finally, a sub n is equal to a sub 1, which is 10 over 9, times my ratio, which is negative 3, don't lose your negative there, to the n minus 1 power, and that is the answer to this one. So that one's got a little bit of stuff to it, but they're definitely doable. Alright, so I'm going to make another video that's going to pick up from where we left off here.